Okay, so let's unpack this because today we are talking about a guy who literally skipped college, built rocket-powered bicycles in his garage, and is now somehow commanding a space empire that's approaching a $40 billion valuation.
Yeah, it's a pretty wild trajectory.
It really is. So, welcome to today's deep dive. We are anchoring this conversation around a really comprehensive research report from Dolphin Research, which was just shared on X by the user KimbaFrank.
Right. And we really need to set the context for the listener here because today is April 16th, 2026.
Exactly, the definitive proving ground year.
Yes, 2026 is the year everyone predicted the new space economy would actually prove itself. Where low-cost launches finally close the loop with these massive satellite networks, and we see entirely new commercial models emerge.
Right, which leads us to the big mission of our deep dive today. We're asking, is Peter Beck and his company Rocket Lab truly the most dangerous future rival to SpaceX? Because right now, SpaceX is the undisputed heavyweight champion of space.
They absolutely are. And it's a phenomenal question because just surviving in SpaceX's shadow is hard enough, let alone challenging them. It requires a totally different corporate DNA.
Right.
And to understand how Rocket Lab plans to step into the ring, you really have to look at Beck's background. I mean, he didn't come from some traditional polished aerospace engineering pedigree.
No, not at
He
all.
started with a tool-making apprenticeship. In the early days, he was literally out there personally welding parts and writing code.
Which is crazy when you think about it.
It is. But that background ingrained this deep, hyper-pragmatic understanding of manufacturing right into the company's culture.
Yeah.
He doesn't view spaceflight as this bespoke, artisanal craft. He views it as a scalable, on-time industrial service.
And that pragmatism, I mean, it completely defined how they survived early on. I've always thought of it using this analogy. So think of SpaceX's Falcon 9 as a massive public transit bus.
Okay, I like that.
It carries dozens of satellites at a low cost per ticket, but it's on a rigid schedule to a very general orbit. If SpaceX is the bus, then Rocket Lab's first rocket, the Electron, is an exclusive taxi.
Right.
It only carries this tiny, like 300-kilogram payload, but it takes you exactly where you want to go, exactly when you want to get there. It fills this massive gap for operators who just can't afford to wait for the SpaceX bus.
And the physics of building that taxi, that's where Rocket Lab really first proved their engineering chops. Because scaling down rocket engines is notoriously punishing.
Because of the pumps.
Yeah, exactly. In a massive rocket, you have these traditional turbopumps. They bleed off some of the rocket's own high-pressure propellant to spin turbines and force fuel into the combustion chamber. And that works fine when your payload margin is huge.
But on a small rocket.
Right, when you shrink that entire architecture down for just 300 kilograms of cargo, all that complex plumbing just becomes way too heavy and completely inefficient.
So, wait, instead of trying to, miniaturize a complex turbo pump system, they just threw the textbook out and bolted electric motors onto the rocket.
It literally did.
Yeah.
Yeah, the Rutherford engine uses what's called an electric pump-fed cycle. They use lithium batteries to drive electric motors that spin the pumps.
That sounds so heavy, though. Batteries are heavy.
They are. And on a heavy lift vehicle, that battery weight would instantly kill your orbital capacity. But on a micro launcher that's built almost entirely out of advanced carbon fiber composites, the math suddenly works.
Oh, wow.
Yeah. And on top of that, they leaned aggressively into 3D printing. The primary components of that Rutherford engine are entirely 3D printed.
Which saves a ton of time, I imagine.
Exactly. It drastically reduces the part count. It turns a manufacturing process that used to take months into a matter of days.
Okay, so they essentially built a carbon fiber, battery-powered, 3D printed sports car for low Earth orbit.
Pretty much.
But, here's the massive roadblock. A boutique taxi company doesn't take down a global transit system.
No, they don't.
The dedicated small launch market has a hard ceiling, and commercial clients are ruthlessly cost-sensitive. You don't become a $40 billion rival just by launching 300 kilos at a time.
Right. And Beck realized that ceiling was approaching fast. To capture those massive commercial constellations and defense contracts, they had to move out of that safe micro-launcher niche. They had to challenge the Falcon 9 head-on.
Which brings us to Neutron, their new medium-lift vehicle. And looking at the Neutron design specs in this Dolphin report, it's just a masterclass in rethinking orbital mechanics.
It really is.
Especially the fairing design, which they officially call the Hungry Hippo, which is just a great name.
It's a fantastic name.
So unlike traditional rockets where the fairing, splits in half and gets discarded or fished out of the ocean, the Hungry Hippo stays permanently attached to the reusable first stage. It opens its jaws, deploys the upper stage and the payload, snaps shut, and flies back to Earth.
Wow.
And if you think about the physics of this, if the fairing stays attached to the first stage, that means the second stage is completely enclosed during that violent ascent through the atmosphere.
Exactly. It doesn't need to survive dynamic pressure or atmospheric heating at all. So you can strip almost all the heavy thermal shielding and structural reinforcement right off of it.
Because it's riding inside a protective shell.
Yes. And in aerospace, every single gram you save on the upper stage translates directly to a gram of paying cargo you can put into orbit. By shifting all that rugged, heavy protection to the reusable first stage, Rocket Lab fundamentally rewrites the cost equation. Neutron is designed for immediate, rapid reusability from day one. It's not an afterthought.
Which totally answers why the U.S. Department of Defense, NASA, and the entire commercial sector are practically begging for this rocket to fly. I mean, nobody wants a single point of failure in their supply chain. Even if SpaceX is executing flawlessly right now, a monopoly inevitably stalls innovation. The market desperately needs a highly capable second option, and Neutron is custom built to be exactly that.
But, having a brilliant CAD model is one thing. The gap between a computer simulation and a functional launch pad is where aerospace startups usually go to die.
Yeah, because building orbital rockets involves taming literal extreme physics and millions of interacting parts.
Right. Which brings us to where Neutron stands right now in April 2026. They are right in the middle of the ultimate testing crucible.
And I really want to break down exactly what that testing gauntlet looks like based on the sources, because it is grueling. A rocket goes through an intense multi-step sequence before it ever even sees a countdown clock, right?
Oh, absolutely. It's a massive checklist.
So first you have the subsystem tests. This means static hot fires for the engines and structural tests where they subject the carbon composite to extreme static and dynamic loads.
Yeah, they are literally bending the metal and carbon until they find the breaking point.
Right. And then comprehensive electrical system checks. And passing all of that just gets you a ticket to the environmental simulations, which sound even more brutal.
They are, because then they throw the components into acoustic chambers, blasting them with sound waves so intense they can literally vibrate materials to pieces.
That's wild. And then thermal vacuum testing, right?
Yes, to simulate the brutal freezing and boiling conditions of an airless orbit.
Okay, so after all of that survives, then you move to full assembly matching, making sure the giant puzzle pieces actually fit together on the pad.
Exactly.
Then a wet dress reversal, which is loading the cryogenic propellants and running the countdown to T0 without actually igniting. And only then, finally, do you get to an actual launch.
Right. And what's fascinating is Rocket Lab is navigating this exact flow openly right now. According to the updates, the new Archimedes engine-powering Neutron has already completed multiple static hot fires.
That's a huge milestone.
It is. The structural testing at both the material and component scale is largely finished, and Launchpad 3 in Virginia is basically structurally complete.
But there was a major setback we definitely have to address. The maiden launch of Neutron was originally targeted for the second quarter of 2026. But the Dolphin report details that in January 2026, a Stage 1 composite tank ruptured during a hydrostatic pressure test.
Yeah, that made headlines.
Right, and if they were doing a hydrostatic test and the tank popped, that means they pressurized it with water until failure. That isn't a design flaw in the aerodynamics, that points to a manufacturing defect, right? Like, should the military or investors be worried about that?
That's a critical distinction to make. And the investigation actually revealed the root cause was a microscopic defect that originated from a supplier's manual layup process.
Manual layup.
Yeah, meaning human hands were laying down sheets of carbon fiber. And when humans do that, tiny inconsistencies naturally occur. At the extreme pressures of a rocket tank, a microvoid in that composite matrix becomes a catastrophic failure point.
Oh, wow. Okay, so this is where Beck's pragmatism kicks in again, because instead of just firing the supplier or trying to patch the tank, Rocket Lab completely pivots.
Right.
They decided to transition the entire manufacturing process away from manual layup over to automated fiber placement, or AFP technology.
Exactly. Utilizing the world's largest AFP machine, in fact. And this is a manufacturing process Rocket Lab already deeply understands. They've used it extensively on the Electron program. Automated laying of carbon fiber tape just eliminates those human inconsistencies entirely.
But that pivot pushed the maiden launch back, right? From Q2 to Q4 of 2026.
It did. But the strategic trade-off there is immense. I mean, they traded a few months of delay for a massively scalable, internally controlled, and highly reliable production pipeline.
So it's taking one tactical step back for 10 strategic steps forward. And honestly, Rocket Lab can afford that delay because rockets aren't even their only business.
No, they really aren't.
If you look at the economics of the space industry, they actually make more money from what goes inside the rockets than the rockets themselves. The launch is just the delivery truck.
The Space Systems division is their ultimate strategic masterstroke. It completely isolates them from the extreme volatility of the launch market.
Let's talk about that, specifically their Photon satellite platform. So, listener, imagine buying a fully functioning, high-end car. The engine works, the navigation is flawless, the power systems are integrated, but the passenger seat is completely empty.
Right.
Rocket Lab builds that entire platform. And the customer just brings their specific payload, maybe it's a multispectral camera or an experimental radar array. They just strap it into the empty seat, and it's ready for orbit. It's a true turnkey solution.
And to achieve that turnkey capability without spending a decade in R&D, Rocket Lab executed this incredibly aggressive, highly targeted acquisition strategy.
They went shopping.
They did. They acquired Sinclair Interplanetary, securing industry-leading reaction wheels and star trackers. They bought Solero to bring top-tier space solar panels in-house. They acquired Advanced Solutions, Inc., or ASI, getting total control over complex flight software and autonomous guidance systems.
So they basically just bought the best-in-class supply chain and brought it all under one roof. And now they are so vertically integrated that they actively sell these individual components to their own direct competitors.
Which brings up a really fascinating dynamic for the broader space economy, because we often wonder, how do normal people, ordinary entrepreneurs, actually participate in this industry?
Right, because building orbital rockets is literally a billionaire's game. The barrier to entry is just absurd.
Exactly. But participating in the satellite component supply chain, that is where the highest added value actually is. And it's becoming highly accessible.
Especially with the integration of AI, right?
Yes, absolutely. If you're a startup today, you don't need a massive physical factory to add value to the space economy. With AI-driven simulations and generative design, a small team can optimize a reaction wheel's efficiency, or they can write autonomous flight software that previously would have required an entire department of engineers.
Wow, so AI drastically lowers the barrier.
It really does. It allows entrepreneurs to create high-value software or component blueprints that companies like Rocket Lab or SpaceX desperately need for these massive satellite platforms. The software and the sensors are vastly more valuable than the aluminum and the carbon fiber.
And Rocket Lab is optimizing its hardware to match this exact reality. Just look at the Flatellite platform they revealed back in February 2025.
Oh, the Flatelites are brilliant.
Right, designed specifically for that hungry hippo fairing. So instead of these bulky cubes or awkward cylinders, the Flatellite platform features extreme modularity and a flattened profile. You can stack them on top of each other as tight as a deck of cards.
Yeah, maximizing the payload volume of every single Neutron launch. It creates this perfect closed-loop ecosystem. The rocket design informs the satellite design, which maximizes the launch economics, and that ultimately drives down costs for the end user.
And those end-user budgets are staggering. We mentioned earlier that the U.S. military and government launch market is worth around $5 billion annually. But the budget for the hardware going onto those rockets, it totally eclipses that.
Oh, by an order of magnitude.
The Dolphin Research Report highlights the U.S. Space Development Agency's PWSA project, the Proliferated Warfighter Space Architecture. Just that single defense initiative is spending billions upon billions.
Because the PWSA represents a total paradigm shift in defense architecture. Historically, the military relied on a handful of massive, multi-billion-dollar monolithic satellites just sitting in high geostationary orbit.
Sitting ducks, basically.
Exactly. Large satellites are easy targets for modern anti-satellite weapons, and they suffer from massive latency issues.
So the military realizes they need a mesh network in low Earth orbit instead. Hundreds of smaller, cheaper satellites. They need a tracking layer of infrared sensors to spot hypersonic missiles the second they launch, and a transport layer using optical laser crosslinks to pass that targeting data around the globe instantly.
Right. And Rocket Lab is positioned perfectly for this double dip. By controlling both the launch vehicle and the satellite manufacturing, they capture margin at every single step of the journey.
It's genius.
They get paid handsomely to build the complex flatellite.
Yeah.
They get paid to launch the flatellite. And they are utilizing their own in-house components to construct both.
So synthesizing all of this, is Rocket Lab the most dangerous rival to SpaceX? Let's look at the historical timeline. SpaceX launched the Falcon 9 in 2010. Rocket Lab is aiming to launch Neutron in Q4 2026. SpaceX mastered reusability a decade ago. Rocket Lab is integrating it right now. They're operating roughly 10 years behind Elon Musk's historical milestones.
And look, a 10-year gap in aerospace is massive. There's
Yeah.
no getting around that. However, the velocity of Rocket Lab's iteration is what makes them truly formidable. They are operating with the immense benefit of hindsight. They don't have to guess if reusability works or if automated carbon fiber placement is viable.
Right, the trail is already blazed.
Exactly. They know the destination, and they are sprinting toward it with extreme vertical integration and that deeply pragmatic corporate culture Beck instilled. Furthermore, they are fueled by this massive, captive market of government and commercial entities that are fundamentally desperate for a viable alternative to SpaceX.
The entire industry has the wind at their backs because this modern space race, it's not about planting flags on Mars or taking billionaires on suborbital joyrides.
No, well,
It is about laying down the foundational infrastructure of the next century. The global communications networks you rely on, the secure data layers, the early warning defense systems, all of it is moving to low Earth orbit. And the rails for this new economy are being forged right now by these competing corporate philosophies.
because the infrastructure dictates the future of the economy. Whoever controls the delivery trucks and the cargo platforms wields immense geopolitical and commercial power.
Which leaves me with one final, slightly terrifying thought for you to chew on. Right now, Peter Beck and Rocket Lab are building the delivery trucks, the Neutron rocket, and they are manufacturing the cargo, the Photon, and Flatellite platforms for other companies and governments.
Right.
But they hold all the keys to the kingdom. What happens when Rocket Lab decides they don't want to just be the ultimate supplier anymore? What happens when they leverage their own rockets, loaded with their own heavily stacked Flattellites, to build their own proprietary mega constellation in low Earth orbit and start competing directly with Starlink for global data supremacy? When does the ultimate supplier realize they have the power to become the ultimate competitor?
Well, when a company controls the entire vertical, from the launch pad to the orbital software, they are no longer just a participant in the space economy. They have the power to completely redraw its borders.